In this part of the application of differentiation, we're going to see how we can make use of differentiation to find the rate of change of a particular quantity. So let's say I have a quantity y, and this y here represents the height of a tree that I've planted. And we have access to the equation that is relating y to the time that is taken for the tree to grow. So let's say the relationship is this: y is equal to, y represent the height of the tree, is equal to, let's say, t to the power of 3 plus 2t, where t represents the number of years that I have planted the tree. So I'm interested in what is the rate of change in terms of the height of the tree after 1 year. So for differentiation, to represent rate of change, it is represented as dy dt. dy dt means it is the rate of change of y with respect to t. So dy dt, using differentiation, dy dt here is equal to 3t squared plus 2. And we are interested in what is the rate of change of the height of the tree after 1 year. So after 1 year, that means when t is equal to 1, then dy dt here is going to be equal to 3 times of 1 square plus 2. So it is going to be 3 plus 2. It is going to be 5, for example, 5 meters per year. Okay, so this here is when I have y being equated to time directly. But what we're going to be facing most of the time in our A math is when y is not related to t directly. Maybe y is going to be related to some other quantities. And how do we find the rate of change if it were to be so? For example, let's take a look at this question over here. Okay, given that y is equal to this, okay, it is not expressed in terms of t. So for a situation that is like this, and yet we still want to find the rate of change of y, which is dy dt, what I want you to do is to apply this, okay, the rate of change equation. So for the rate of change equation, it is dy dt is equal to dy dx multiplied by dx dt. This is actually pretty easy to memorize because we can sort of like imagine, okay, we want dy dt, which means that if I were to be able to re-express it in terms of something that is like this, then this dx, it seems like it can be cancelled, although we know that cannot happen because dy dx itself, dx dt itself, they are just notation. Okay, it doesn't mean that it is dx divided by dt. But, you know, like just for our imagination wise, we can imagine it as if dx and dx can be cancelled, so I'll be left with a dy dt. So this rate of change equation, let's make it a point to memorize it. And the process to calculate for a situation that is when y is related to x, for example, is the first thing that you want to do is to find dy dx, like what I've written here in the outline also. And the next thing that you want to do is to calculate for whichever quantity that the question is asking you for. And the question will usually ask you for x, ask you for dy dt, or ask you for dx dt. It depends on the question. We're going to explore that in a short while. And they will always ask you for that particular quantity for a specific situation. That means the question will tell you when they want you to come out, when they want you to analyze the rate of change of that situation. Okay, let's take a look at an example, and I think this will become very, very clear to you. So let's come back to this example that we have here. Let's take a look at question number 1. So in question number 1 here, we are given that y, let me write it down, okay? Y is equal to 2x squared minus 3x. So we are supposed to find the rate of change of y. So we want to find dy dt. So it is this case here. We want to find dy dt. The question says we want to find dy dt when x is equal to 2. That is the specific condition that we are talking about. And given that x is increasing at a rate of 3 units per second, so for this question, we are given dx dt. Given that x is increasing at a rate of 3 units per second, this says that dx dt is equal to 3. Let's try to find the rate of change of y. Let's try to find dy dt. So to do that, the first thing that we want to do is to find dy dx. So from here, let's find dy dx. dy dx is going to be 2x here, then minus 3. So we have a 4x minus 3. This is our dy dx. And the rate of change equation is going to be this. dy dt is equal to dy dx times dx dt. And this happened at that specific condition. So I want to list down that specific condition in this question here. It is when x is equal to 2. There's another condition that is actually also given to us. So I'm going to write it down here. The question says that x is increasing at a rate of 3 units per second. So I'm given this by the question also. So now it is this scenario, this second scenario that we have here for this particular question, because we are lacking in dy dt. So I'm going to try to find the other two first. Now this is already given. So the next quantity that I'm going to try to find is dy dx, and we can find dy dx because we already have the expression for dy dx for x minus 3. So we just want to find what is dy dx when x is equal to 2. So we have a 4 times 2 minus 3. This is equal to 5. And now we are ready to find dy dt. So I'm going to quote the rate of change equation. Dy dt is equal to dy dx multiplied by dx dt. So dy dx here, this is equal to 5 times dx dt. This is given to us as 3. So dy dt, the rate of change of y for this case is 15. Let's take a look at another question. Let's take a look at question number 2. So in question number 2, we are given that y is equal to sine of 3x minus pi over 3. And what the question wants us to find is the rate of change of x. Okay, so we are looking at this situation here. Find the rate of change of x dx dt, which means that we want to find dy dx and dy dt. Then subbing these two values back into the rate of change equation, we should be able to find dx dt. And the first thing that we want to do is actually to differentiate this with respect to x. So let's do that. Dy dx, this I'm going to apply the chain rule. So seeing this as u, so sine u, differentiating this with respect to u, it is going to be cosine. Okay, I'm writing it wrongly. So here is cosine. So it is going to be cosine of 3x minus pi over 3. Then differentiating u, this is going to be equal to 3. So this is 3 cosine of 3x minus pi over 3. So dy dx is equal to this. And we are supposed to find dx dt when x is equal to 3 pi over 2. So that is the condition that is given to us to find the rate of change. So I'm going to quote it here, when x is equal to 3 pi over 2. So we are looking at this situation. We want to find first dy dx and then dy dt. The question actually gave me dy dt. Okay, the question says that y is decreasing at a rate of 0.19 units per second. Let's take note of this word decreasing. If you were to look at question number 1, question number 1 was increasing. So just now when we were doing question number 1, dx dt was quoted as 3. Dx dt was equal to 3. But now, when y is decreasing at a rate of 0.19, it will be wrong if I were to just write dy dt is equal to 0.19. Okay, why will this be wrong? Because in the previous scenario, it was increasing, and now it is decreasing. So I have something that I think you should take note of, which is if the question were to say that a quantity is decreasing, for example, in this case, x is decreasing at 2 cm per second, then dx dt will be equal to minus 2. Because as time increases, x will decrease. So the rate of change is supposed to be negative. So you need to add in this negative yourself. So coming back to this question over here, since the question says that y is decreasing at a rate of 0.19, so we want to add in this negative. And the next thing that we want to do, since we already have this, is to find the quantity for dy dx. So for dy dx, I'm going to make use of what we have found previously. This is 3 cosine of 3 times of 3 pi over 2 minus pi over 3. And I'm going to make sure that I'm in the radians modes, because by default for calculus, all the angles should be by default in radians. So if I were to go for the radians mode, pressing this to the calculator, I'll be able to get a 2.5981 to 5 significant figures. And now I'm ready to quote the rate of change equation, and I'm going to quote it as dy dt is equal to dy dx multiplied by dx dt. And what is dy dt? This is minus 0.19. What is dy dx? This is 2.5981, and dx dt is the last unknown that we are supposed to find, and that will help us to achieve what the question also wants us to find. So from here, dx dt. This is equal to minus 0.19 divided by 2.5981. Pressing this into the calculator, my answer is negative 0.0731. Let's take a look at another example, question number 3. So in question number 3, we are given that y is equal to 1 over 3x multiplied by x squared minus 7x plus 4. And now we are told that y is changing. Okay, they didn't use the word increasing or decreasing. They say that y is changing at a constant rate of 2.3 units per second. The question also mentioned that x is changing at a rate of 0.5 units per second. So if the question were to use the word changing instead of increasing or decreasing, and when it is in decreasing, we need to add a negative to the rate of change because the quantity is decreasing when time increases. So for changing, how should we manage this? For our syllabus and the way that we are going to be examined, when the question says changing, you can safely make use of, see it as if it is increasing. Okay, which means that if it were to be decreasing, the question will explicitly mention it to you. But if it is increasing, the question will either, of course, the question can explicitly mention it, or if it is just taken as changing, then you can just go for whatever quantity that is given to you in this case. So for now, we are given that dy dt is equal to 2.3. We are also given that dx dt is equal to 0.5. And what we are supposed to find is x. That's what the question says. Find the value of x when x is changing at 0.5 units per second. So we are looking at scenario number 1, where x is the unknown. So in the rate of change equation, where is x? X will reside within dy dx. Let's take a look at the question. So in this case here, I'm going to find what is dy dx. That is the first thing that we should do. And to find dy dx, should we try to apply the product rule? I don't think so. If we were to apply the product rule, it is going to be unnecessarily complicated and tedious, because we can do a simple manipulation instead. For example, what if I were to just multiply this in? So I'm going to be getting a 1 over 3 of multiplying this in x to the power of 3 minus 7x squared plus 4x. And now this is easy to differentiate. I don't even need to apply the product rule, neither do I need to apply chain rule. It is just a simple differentiation. So 1 over 3 is a constant. I'm going to let it be. Differentiating this is 3x squared. Differentiating this is going to be 14x, and differentiating this, we are going to get a 4. So dy dx is equal to this. Let's quote the specific condition. The question says we are supposed to find the rate of change of x when x is changing, so dx dt. When x is changing, so it is not x here, it is dx dt. So dx dt is given to us as 0.5. We are given another condition, which is dy dt. dy dt is given to us as 2.3. So we are given both this and this. So we're given already this and this. And now since this is the only unknown that is left, it is time to quote the rate of change equation. So let me quote it here, dy dt. This is equal to dy dx multiplied by dx dt. So dy dt, this is equal to 2.3. So I'm going to write it down here. dy dx, it is equal to this, 1 over 3 of 3x squared minus 14x plus 4. Again, just to repeat, this dy dx is where x lies. Okay, which means that if I'm supposed to be solving for x, x is going to be found within the expression for dy dx, which we are seeing here. And dx dt is equal to 0.5. And if you were to manipulate this equation, you will be getting x squared minus 14 over 3x minus 49 over 15. This is equal to 0. And I can just press this into the calculator to solve for x. Pressing this into the calculator, x is equal to 5.28, or x is equal to negative 0.618. We are going to be rejecting this. Why? Because the question says that x is bigger than 0. So this is going to be rejected. Let's take a look at another question, question number 4. And in the next question, we are given a rectangle. And in this rectangle, it has a constant perimeter of 36. the breadth of the rectangle is given to us as x, and this x is decreasing at a rate of 0.4, which means that dx dt is equal to negative 0.4. And we are supposed to find the rate of change of the area. And if I were to let the area be represented by a, what the question wants us to find is dA dt. When x is equal to 12, that is the condition that is given to us by the question. So if this is the rectangle, we're given that the breadth is x, and if a represents the area of the rectangle, area is breadth times length, and we don't know what is the length. I'm going to go for y to represent the length, and a is equal to x times y. But we can't proceed with an equation that is like this. We can't differentiate. We can't even start the first process here. So what we want to do is to try to first express a in terms of x. And can we do that? Yes, we can, because the question actually gave us a condition. The condition is that the perimeter of the rectangle is a constant of 36, which means that x times y, x plus y plus x plus y, which is the perimeter. So x plus y plus x plus y, this is given to us as 36. So 2x plus 2y, this is equal to 36. I can express y in terms of x now. Y in terms of x, this is equal to 18 minus x, which means that a is going to be equal to x times y, which is 18 minus x. So a is equal to 18x minus x squared. So now I have a in terms of x. If I were to execute the first step here, customizing it a bit for this question, we are going to go for a dA dx, which is equal to 18 minus 2x. Because what we have in mind is, if I were to be applying the rate of change equation to a scenario that is like this, customizing it for this question, this will become a dA dt is equal to dA dx multiplied by dx dt. My inspiration comes from the fact that I can find dA dx, which exists here. If dA dx is here, then here must be dx dt, so I can visualize it as if these are fractions, but we know that they are not fractions. But if we were to visualize that these are fractions, then dx and dx can be cancelled, and that will give me a dA dt. So I'm going to be applying this rate of change equation later, and now I've already gotten this and this. And what we want to do next is to highlight the specific condition where the unknown is supposed to be found, and that is when x is equal to, according to the question, 12. So when x is equal to 12, we are given that dx dt, the rate of change of x, according to the question, x is decreasing. So minus decreasing at a rate of 0.4. So this is given to me by the question. And we're going to next find what is dA dx. So dA dx. dA dx is going to be equal to 18 minus 2 times of x, which is 12 over here. So dA dx is equal to minus 6. So we have found out what is this quantity, we have found out what is this quantity, and now we are ready to find the last quantity, which is dA dt. So this is done, and this is what the question is asking for. So now I'm going to quote the rate of change equation. dA dt, this is equal to dA dx multiplied by dx dt. dA dx is equal to minus 6, and multiplied by dx dt is negative 0.4. So dA dt is equal to 2.4. Let's take a look at the last question. And in this last question here, we are looking at a spherical balloon with a radius of r, and we are given the surface area to be represented by A. We are also given that the volume is represented by V. What we want to do is to find the rate of change of increase of the volume. That means we want to find dV dt, and the condition is when r is equal to 1, if r represents the radius. So what we are going to do is to find dV dt. We're going to try to make use of the rate of change equation, but what we are also given is dA dt. The question says that A is increasing at a constant rate of 0.1. So with the information that is given to us so far, it seems to be suggesting that we probably can try to consider a dV dt is equal to dV dA multiplied by dA dt in order for us to find dV dt. So to find this, we're going to attempt to get this and this. dA dt is already given to us, which means that we will need to work out a dV dA. But to work out a dV dA, we need V in terms of A in order for us to differentiate V with respect to A. And this sphere, volume and area, we don't really have an immediate equation that relates the volume to the area. Can we find that? Yes, we can, but it is going to be more tedious and unfamiliar to us. So I want to present to you a strategy. Okay, we're going to be stretched a little bit through this question. So instead of doing this, let me show you what we can do. Okay, we are still going to be finding dv dt. So to find dv dt, let's use a more familiar equation first. So the more familiar equation is volume in terms of the radius. So volume is going to be 4 over 3 pi r to the power of 3. Because if I have this, then we can very easily differentiate this with respect to r, which will give us a dv dr is equal to 4 over 3 multiplied by pi. Okay, let me erase this. It is going to be 4 over 3 pi. 4 over 3 pi is a constant, so differentiating this is 3r squared, which gives us a 4 pi r squared. So what I plan to do is to execute the rate of change equation to this. And customizing it for this question, dv dt is supposed to be equal to dv dr times dr dt. Okay, it seems to be quite okay so far, right? Because I'm using an equation that I'm used to, and we can differentiate it very easily. And the specific condition that we are looking at is when r is equal to 1. So when r is equal to 1, can we find dv dr? Yes, we can. So let's find dv dr first. Okay, then that will be dv dr. This will be equal to 4 pi r, which is 1. So 1 squared, so this is 4 pi, which means that we will be able to find this, but this is still missing. And if you were to look at the question didn't actually give us dr dt. And we are still supposed to find this, and that is not possible. We need a dr dt. So how do we find dr dt? We're going to make use of the other information that is given to us, which is A is increasing at a constant rate of 0.1. And we have access to the surface area of the balloon. So before this, if I can just do this strategic planning, I'm going to also quote A in terms of R. And the formula teaches us that this is equal to 4 pi r squared, which means that dA dr is going to be 4 pi multiplied by 2r. This is equal to 8 pi r. So the rate of change equation, when it is customized for the surface area of the balloon, in this case, dA dt is equal to dA dr multiplied by dr dt. And if I were to just quote the specific situation that we are looking at, the specific condition that we are looking at, and that is when r is equal to 1. So when r is equal to 1, we are given that dA dt, the rate of change of A, according to the question, it is increasing at a constant rate of 0.1. So this is equal to 0.1. And we can also find dA dr. dA dr is 8 pi multiplied by 1. So this is equal to 8 pi. So for the rate of change equation that I will be quoting next, I've already gotten this. And I've also gotten this. So which means that now I can find the last unknown quantity, which is dr dt. So quoting the rate of change equation, dA dt, this is going to be equal to dA dr multiplied by dr dt. dA dt is equal to 0.1. This dr dt is equal to 8 pi multiplied by dr dt tells me that dr dt is equal to 0.1 divided by 8 pi. And now I have the quantity dr dt. And now I can also substitute this quantity when r is equal to 1 into here. So from here, dr dt is 0.1 over 8 pi. And now I have dr dt. I'm going to be left with just one last unknown, which is what the question wants us to find, dv dt. So from here, I'm going to quote the rate of change equation. dv dt is equal to dv dr multiplied by dr dt. dv dr is this, which is 4 pi multiplied by dr dt. This is equal to 0.1 over 8 pi. And this is equal to 0.05. And this helps me to round up what I want to discuss with you guys about how we can apply differentiation to find rate of change of a quantity. And if you are ready, let's move on to the next part of the chapter.